Now, I've mentioned many times before, in this lectures, death of the microbe, death of the microbe. One of the things that we have studied, we've discovered, and we've studied over the decades is that even though some compound will kill microbes, will damage endospores, there is certain factors, certain characteristics of the microbes, the contamination, that we have to take into account. Things that are going to affect what we refer to as the microbial death. So when you look at these factors affecting the death rate, how many death rate, meaning how many microbes are going to die, how quickly, how many will be left. These are all things that will come into play, will be part of the overall calculus and the calculation of a death rate. So when you look here on this slide, 6 things that scientists, as they're designing new chemicals and compounds, administrators in the hospitals, the experts who are trying to determine best practices. These are 6 characteristics of the contamination we have to take into account. First being the number of microbes. A contamination that's only a few microbes present versus something where it's billions and billions and billions of them. 99.9%, Lysol kills 99.9%. This detergent, blah, 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 99.5%. Well, 99.5% of a few hundred microbes versus 99.5% of a few billion microbes. Still leaves you a lot either way, but one can be dealt with a lot easier than the other. And then what microbes are present there? Think back 2 lectures ago when we were looking at the illustration of levels of resistance. Are you talking, some of the gram-positive microbes that are, easily damaged? Or are you talking things that are more up the scale that are heavily resistant? What's there? What's not there? Can have an effect on, how quickly a surface will be decontaminated, how quickly a surface could be sterilized. Temperature and pH, what's the temperature of the environment? What temperatures can, the object you're trying to decontaminate, try to sterilize? What levels of temperature, what levels of pH can it withstand before the surfaces become damaged, before the internal workings, the electronics become damaged? Also have to take into account, the concentration of whatever chemical compound, your agent you're using. Turns out, one of the weird things I've learned over the years, when people are presented with 2 spray bottles in the lab and say, here, these are alcohol solutions. Spray down, let it set for a few minutes, wipe up. Inherently, we just seem to think that the bottle that has 100% alcohol should be better at decontaminating, better at cleaning than the spray bottle that has 70% ethanol. Just in our head, 100% is much better. It's pure. Nah, turns out it's the opposite. Turns out the 70% just works better. So something we have to take into account is concentrations of the chemical, the compound that's in an aqueous solution or it's in some sort of a solution. What concentrations? Too much, too little, just right. Then mode of action. As we saw 2 lectures ago, the different mechanisms, X-rays versus gas versus heat. Nothing's instantaneous. Different mechanisms, different ways that these treatments work means it's going to take different times. Means we're going to have to look at, is this methodology, spraying with this chemical compound as opposed to with this one, is it going to work better? Is it going to work quicker? What exactly does it damage? What exactly does it do to the vegetative cell? And then lastly, what else is there that could be interfering, could be absorbing up the chemical so that the microbes present are never actually exposed? In a surgical wing, this could be blood, this could be tissue matter. Blood, tissue, stuff like that gets into crevices, in certain places in the surgical wing. Well, guess what? The blood, the tissue that's there, that could be in the crevices of the scalpel, could be in the crevices of the scissors that were used. Any nicks, scrapes on the instruments or probes could harbor the blood, the tissue, which are going to soak up any chemical compound so that any microbes present just aren't going to get the full treatment and may or may not be damaged or interfered with in any way.